Have you ever glanced at the ingredients on, say, your favorite soda or multivitamin and just kind of wondered, where does something like citric acid actually come from? Well, the answer might surprise you. Turns out there's a hidden world of microscopic factories all around us, and they're busy creating things we use every single day.
So let me ask you this. What could possibly connect the sharp, tangy taste in your drink, the vitamin C you take to stay healthy, and maybe even that compostable fork you used at lunch? I know, it sounds like a totally random list, right? But believe it or not, the answer for all of them is the same. It's a powerful and really elegant biological process.
Okay, let's dive into what that means. For a long time, making a lot of these compounds meant using chemical synthesis. Stuff that often relies on petroleum and fossil fuels, which, as we know, can be pretty tough on the environment. But now, there's a new way that's really taking over: microbial fermentation. It's a total game changer. This process uses renewable things, like simple sugars or even agricultural waste, to get the job done. And it does it in a cleaner, more sustainable, and often way more precise way.
So how in the world do we actually turn these tiny little organisms into industrial powerhouses? All right, let's pull back the curtain and take a look at how this micro production line really works. The technical name for this whole thing is a microbial bioprocess. But don't let the jargon fool you. The idea is actually pretty simple. We're basically harnessing nature. We're giving microorganisms, like bacteria or fungi, a very specific job to do. Here, eat these raw materials, and then, through your own natural processes, create something really valuable for us.
The best way to think about it is like a microscopic factory assembly line. It's got three main stages. First up is what we call upstream processing. This is all about prep work, making the perfect nutrient soup for our microbial workers, and making sure all the equipment is sterile. Then comes stage 2, fermentation. This is the main event. It's where the microbes feast on that soup and produce the exact thing we want. And finally, there's downstream processing. This is basically the cleanup and packaging phase, where we separate, purify, and get the final product ready to go.
Okay, so that's the theory. But let's see how this plays out in a real world. We're going to start with a case study you can literally taste. The really surprising story behind that sour tang in so many of our drinks.
So for more than 100 years after it was first discovered in 1784, the only way to get citric acid was, well, from lemons. But then, in 1917, a chemist named James Curry made an absolutely groundbreaking discovery. He found that a common black mold, Aspergillus niger, and yes, I mean the same kind of stuff you might find on old bread, could pump out citric acid in huge quantities. And when World War I cut off citrus supplies from Italy, companies like Pfizer jumped on this new microbial process, and they changed the industry forever.
And just how big of a change are we talking about? Today, over 90% of the world's citric acid is produced by microbial fermentation. That's right, the sour taste in your favorite candy and soda almost certainly comes from a fungus, not from a fruit.
I mean, that is an incredible industrial takeover. But it kind of begs a fascinating question, right? How on earth do you get a fungus to cooperate and turn itself into a tiny, hyper-efficient acid factory?
Well, it all comes down to some really clever biochemical manipulation. It's like a secret recipe for stressing out the fungus in just the right way. See, we feed it a ton of sugar, but then we starve it of other key nutrients, like nitrogen and phosphorus. This basically tricks its metabolism. It's like we're telling it, hey, stop growing and just start making acid. And on top of that, we have to keep manganese levels incredibly low and maintain a super acidic, oxygen-rich environment. We are, for all intents and purposes, hacking its biology to do what we want.
And this powerful technique isn't just for making things taste sour. A very similar process is used to produce another organic acid, lactic acid. And this microbially produced acid just so happens to be the key building block for what's called polylactic acid, or PLA, which is one of the most common biodegradable plastics out there, used in everything from 3D printing to food packaging.
So, we've covered acids for food and for plastics. But these microbial factories are incredibly versatile. So now, let's see how we can expand the product line to manufacture something absolutely vital for our health: vitamins. Now, to get this next part, there's a really cool concept called biotransformation. See, instead of asking a microbe to make a whole product from scratch, sometimes we just needed to do one single, very specific, and often very difficult chemical step for us. In this case, the microbe becomes like a highly specialized, microscopic surgeon. And the way we make vitamin C is a perfect example of this. It's this brilliant hybrid process. So it starts with a simple chemical step. But step 2,
Step 2 is where the magic happens. A bacterium comes in and performs one single, perfect biotransformation, a step that is incredibly hard and expensive to do with just traditional chemistry. But the microbe does it easily. And from there, it's just back to chemistry for the final conversion. It's a perfect partnership, really, using the best of both worlds.
And we're not talking about some niche, lab-scale thing here. The annual global production of vitamin C using this hybrid method is over 40,000 metric tons. That one little microbial step is absolutely essential to making this happen on an industrial scale.
Okay, so from the acid in our soda to the vitamins in our supplements, we've seen how these tiny factories do their thing. So let's bring it all together, because the future really is fermented, and this is why it all matters so much.
The advantages here are just enormous. These processes let us use cheap, renewable stuff like molasses or corn waste as our raw materials. That means we reduce our reliance on fossil fuels. We can create highly complex and pure molecules that are tough to make otherwise. And at the end of the day, all of this powers a much more sustainable way of manufacturing things.
And look, this is a very real shift that's happening right now. As the source material for this explainer puts it, improved fermentation is actively replacing traditional chemical processes for all sorts of high-value products. We are living through a quiet, microscopic industrial revolution. And that really brings us to our final thought. We figured out how to harness these ancient little life forms to turn sugar and waste into modern plastics, foods, and medicines. It really makes you wonder, as we get better and better at this, what in the world are we going to ask these tiny factories to create for us next?